In this video, we're continuing with Chapter 8. We're going to look at area of triangles and kites. So let's look at the relationship between a triangle and a kite. So let's start with a sketch. If you recall, a kite has two pair of disjoint or two separate pair of congruent segments. So here's our kite. We have a pair of congruent segments on the top and a pair on the bottom. And then I'm going to draw the diagonal. So remember, a diagonal connects two vertices that are not next to each other. So the top and the bottom, I'll connect those. That's one diagonal. And I'll connect those vertices as well for the second diagonal. So now what we can see is I have an isosceles triangle on the top, and I have an isosceles triangle on the bottom. And then this piece in the middle, which is now green, that's a common base. So a kite is two isosceles triangles connected by a common base. All right, and then let's also take a look at the left side here and the right side here. That's also two triangles with a common base. And we can see that these two yellow sides are congruent, these two blue sides are congruent. And then this side that runs down the middle, that is also part of both triangles. That's a reflexive side. So now the left side and the right side, the way I've drawn this, are going to be congruent. And we're going to use that in just a minute to help us find the formula for the area of a kite. So let's take a look here. What's the formula? So again, I'm going to break this down into a left side and a right side. Okay, and then my diagonal 1 is going to be this diagonal that goes down the middle, and my diagonal 2 is going to be the diagonal that goes left to right. So let's start by just looking at this left side. So I'm going to redraw it over here. So here's my left side, and the distance from the top to the bottom, that's going to be my diagonal 1 distance. That's the green distance, diagonal 1. And then I'm going to draw in half of D2. So I'm only going to go to here. So this is D2 divided by 2, and that's, we'll color code that purple. Alright, so if you recall, the area of a triangle is base times height divided by 2. So for this one, our base is going up and down. You maybe turn your head so that D1 is flat on the ground, but our base is going to be D1, and our height is going to be D2 divided by 2. So now the area of that triangle becomes D1 times D2 divided by 2 all over 2. Alright, so here's my base 1. My base is my D1, and my height is D2 divided by 2. And then if we simplify this, it's going to end up being D1 times D2 divided by 4. Alright, so if you just want to take a leap of faith here and trust me that if I simplify all this, it becomes D1 times D2 divided by 4. So now that I have the area of half of this kite, just the left half, the area of the kite is going to be 2 times the area of the triangle. So it's going to be 2 times d1 times d2 divided by 4, which becomes d1 times d2 divided by 2. So the area of the kite. So let's write this out in words. The area of a kite equals half, that's the divide by 2, the product, remember product means to multiply, of the diagonals. Okay? So area of a kite equals half the product of the diagonals. So you multiply the two diagonals. Remember, make sure you multiply. Multiply the two diagonals, divide by 2, and that will give you the area of the kite. So let's go ahead and recap this over here. Area of a kite is given by the formula A sub kite. Area of a kite is equal to d1 times d2 divided by 2, where A is the area, d1 is the length of one diagonal, d2 is the length of the other diagonal. All right, so that brings us to the end of this. If you have any questions, make sure you get those answered. And again, if you notice here, this is for a kite or a rhombus, because a rhombus is also a kite. If you remember that from our quadrilateral family tree. Okay, make sure you get this formula on your formula sheet for the unit, and we'll see you next time.